Hello, fellow Voron builders. I'm CRIMP, and today we're going to finalize our Stealthburner faceplate. We're going to get our accessory board in there for our NITEHAWK. We're going to repin some wires. We're going to talk a little bit about CAN versus USB, and then finally see how it all looks. So check out the video. We are installing the NITEHAWK on this. So there's a couple things we got to do in preparation for that. First of which is this little board right here. Needs to go in. It's going to sit something like so. And to do that, we'll pull these screws back out. I feel like I just mentioned we might have to do this. Now, I don't recall if these screws are long enough to use as is, or if we have to get slightly longer screws. And actually, before we do that, let's talk about this board a little bit, because there's a couple of things going on here. One is this connector here, this 8-pin connector, is what's going to connect this board to the main board that's going to be sitting inside the tool head. This guy right here. But there's also these connections here. We have fan and we have our LED and some other things on here that we can use if we decide to. So these right here, at least the new ones that they have here, are actually recessed. Some of these older boards actually had them on top. So what would happen is this would stick up a little bit too far and you couldn't actually get your head on there the way you wanted it. But I don't know if that's going to be an issue now. I'm interested in seeing that actually. So let's see. This is our LED connector, which isn't the same connector. So we're going to have to do something with that. We can repin that. And these are going to be fan connectors. And again, we have to repin these. So what I usually do, and I don't know if it's even worth on this one because these look like they're epoxied on here. I guess that's just a glue. Okay. So what I used to do is I used to desolder these connectors and solder directly to the head. And I did it for two reasons. Reason one being that it made everything a little bit thinner, made the package a little bit better. And two is, chances are if you're removing any of these parts, you have to get in here anyway. So desoldering it, which is a rarity, really isn't that big of an idea. So having a connector that's built inside of something didn't really seem all that important to me for the instances where you'd actually take it apart and utilize it with that connector. So now that they've recessed these connectors a little bit, everything seems a little bit nicer. And because of that, I think we're going to repin and go into these. Now this kit includes parts to repin your wiring. It's a very nice kit. It also comes with your umbilical cord to bring your USB. This is a USB controller, and your power up. It's got your jumper wire for your 24 volts down at the board. It's got your component here to bring 24 volts into the USB. So USB type C, 24 volts, and then the multi-pin connector out to bring it all back up to the head. So basically this will connect down underneath in the electronics bay like that, bring power and USB all the way up to the head. The only thing it doesn't include that I wish it did is some sort of USB hub. So if the main board is at top had a USB hub, that'll allow you to do like your nozzle cam, your beacon, those types of things through the single USB port. Because it doesn't, you have to run multiple USB cables, or you have to come up with your own little USB hub, which I have one. We're not putting that in right away, but basically I have a 1 to 2 USB hub. And the argument or an argument that's given as to why USB is not good for this situation is because on a CANBus, you can run those things in serial. You just have to basically end it with a resistor. On USB, you have to have some type of bus controller to allow to have multiple USB connections on one, which I 100% agree with. That is a downfall of USB versus CAN. But here's the thing. CANBus is for low speed data, which means it will never do a nozzle camera. As far as I know, unless you're using a really low resolution with really low frame rate, you're never going to get nozzle camera information over CANBus. Or you have a really high-end board at the camera to compress it way down or something like that. But that's one reason why I'm not so big on CANBus. The other reason is CANBus as a protocol, as a device, was really meant to be used in automotive and in factory settings where you're running things long distances to communicate with each other. It's not meant really for short distance type of things. I always scratch my head about CANBus on printers. I'm not a big fan of the whole thing. And then on top of all that, to do CANBus on a lot of printers, you have to first go to USB and then to CANBus. So you need a USB to CANBus controller. CANBus in and itself, if you're not converting it, is actually quicker and more fault tolerant than USB. And the argument is that it's more fault tolerant and quicker than USB. Problem is 99% of the time you have to connect to the unit, meaning your Pi or your MCU, whatever you connect to via USB before you go to CANBus. So you're dealing with USB latency, the USB issues, and then compounding that by adding CANBus on top of it. So that's why I'm going USB. I think USB is a great way to go. That's my argument. So anyways, parts and pieces in the kit, they give you your JST connectors, they give you some ferrules, they give you screws. They pretty much give you everything you could need to hook this thing up. A micro fit connector and some more JST PH, these JST XH, and some more screws. So we're going to put the ferrules away, the screws away. We don't need that either. And I'm going to put this in here too. I'm going to put the main board away. And we'll put the converter board away. I'm going to throw away this stuff. We'll put this back in the box so we don't lose it. And we'll look at what we're dealing with here. So we have to make some connections. Just for reference, these right here, these slightly larger ones are JST XH, and these smaller ones right here are JSH PH. So we have PH and XH, because why not have 5 different connectors used in a printer? You know, make it fun. All right, so we're gonna have to get some wires here. We're gonna wind up cutting all these wires because none of these connectors are the ones we need. So I guess first and foremost, let's see if we probably got the right screws to mount this in here. This box we just slid away. 3x10, 3x6 machine captive screw. Guess maybe? We'll try to use captive screws. They look like they will fit the right purpose. I'm not sure if they're going to be too big. I guess first, let's try the originals. How about that? I will say one thing, this board has some leftover residue, maybe some flux or something on it. I can kind of feel it. So these are not long enough to fit. So those are out. Don't like how big these heads are. I'm not a fan of that. But let's see what we get. I guess they're pretty flush with the back here. Just for giggles, we do this. Wouldn't be too bad. It's a little bit of a not a big fan of that screw. But I guess for now we'll put that in there for funsies sakes, because we need to figure out how we're going to cut these wires. So over here, looking at the pinout of this extender board, we have our part cooling fan, we have our NeoPixel, and we have a hard end fan. Those are the three things that we have wiring for here. So our NeoPixel first is going to wind up right here. And we don't want to cut these too short. And we do want to slide our color coding down. Now on these, just so you're aware, red is power, black is ground, and green is signal. So that will come in handy because we're going to need to know that when we pin this in. And I think we want to do that over here. Like that. It's going to be something like that. And we got some wiggle room here. So I'm going to cut these a little long. I'm going to come up here. Nice and flush. Like so. And then for our hot end fan, again, I'm going to come a little bit long, right about there, like so. And then for our part cooling fan, this one I'm going to hold it like so. I'm actually going to use most of this and cut that one off too. So let's do the part cooling fan first. Let's get all crimpy. Let's separate the two wires a little bit. You can use some standard wire strippers like this. These will work fine. Like so. And if you wanted to, you could tin these. There's arguments in both directions. I'm not going to tin them. The argument against tinning them basically is if you tin the wires, meaning putting solder on the wires, you will basically make it so that as they get crushed, you'll have a weaker crimp on there. So we're not going to do that. This connection up here is a JST-PH, so we're going to need these right here. And we're going to need a, connector. Actually, all these are JST-PHs. So why don't we just take all three out? Like that. And we're going to need 2 of these. One there. And if you're having trouble with this, if you fold that back, do that. We have our 2 for that. And then the fun part, crimping them on. I like these eye crimps. They work really well. There are tons of different crimpers. I can tell you some are good, some are bad, but you know what? Use the ones that you're most comfortable with, because in the end, that's really what matters. Looks better. I think we crimped it just a little bit too hard, but it looks salvageable. Big thing is we want to make sure that under the first section, you're crimping the outer of the wire, the insulation of the wire, and on the other section, you're going to crimp the inner of the wire, the actual metal. So. And that one is perfect. There we go. All right. So 2 wires, we want basically the inner and the outer. So on the board here, basically this is our positive and this is our negative. So we want our positive pin to go over here, and we'll see this is keyed to go in one direction, which is like that. So we need to make sure is we get our positive on this and our negative on this, and we don't need anything in the center. So positive pin needs to go in first. And then our negative pin. Motion holding good. And then once they're both in there, should be able to knock that right in. There we go. All right, I'm gonna get the rest of these crimped up. Hopefully I speed this up and do one of those time-lapsey thingers or something, so you guys don't have to be bored with all this. So here we go.
Basic idea is that there's a groove that I can follow that's exactly right for me to live in an optimal way.
Oh, my eyes aren't getting younger. All right. Now, if you're the really resourceful type, you want to save this type of stuff, You can depin these. Some of them are easier than others, some of them harder than others. I personally don't think it's worth it. But if you wanted to, you could. Um, I guess as a side note, usually there's like a little section on the backside here that you can slide a little tool into and then force it down and pull the wire out. But I'm not even going to mess with that enough to do that. So yeah, you can chuck those as far as I'm concerned, unless you're really into recycling. All right, so there we go. We have our Stealthburner head, 100%, one hundo there. And then this right here, just to give the last final visual of this. Is going to be plugging into this board via this connector on the front, like so. So what that enables us to do is be able to disconnect, and this is kind of the de facto way this is done now. Before, every single one of these wires actually came out and then went to the harness directly. And then at one point there was a multi-pin, like a, I don't remember how many pins, maybe it was like 16 or 24 pin connector that everybody went to, but now everybody's gone to these boards, which are nice, you know. So as the hobby grows and as these hobby printers become more popular, what you wind up with are manufacturers making products that would be really difficult for the hobbyists to make, but relatively easy for a large company to make in mass. So yeah, so there you go. Pretty cool. Couple things I'll mention here. When I finished up the LED unit, I made sure I slid up these color-coded connections so I could see what they are if I ever have to take this apart and look at it. Do be sure to get your colors or your polarities correct on your fans. If you don't, then that could be an issue. You will have to reroute your wires possibly again. Just make sure that there's nothing holding these units from getting into where they need to get to. And you can always just take your parts and kind of dry fit them together to make sure everything is working the way it should. Actually, while we're at it, we might as well kind of show what we're working with here in terms of what this is going to look like. So that's it right there. That's our Stealthburner. Pretty cool. I like it. So there we go. Awesome. Stealthburner.